Okay, people are starting to come in. You see the desktop? Is it look right?
Yes.
Okay, great. Okay. Okay, first let me ask, has anybody got a question about the homework assignment? There was a, um, I don't know what that is. Jeez. These pop-ups make me lose my mouse. It's weird. I don't know if you saw the pop-up, but the pop-up popped up and somehow I lost control of my mouse while the pop-up was up. Okay, geez. All right. First, there was a new homework assignment. Okay. So far, has anybody got any questions about the homework assignment? Any questions that'd be worth going over right now? Any questions yet? You know, if any, if you know, if questions do come up, please ask. Whenever they come up, especially because if anybody finds something funny in it, it'd be helpful to know so it gets fixed. So, yeah, the sooner it gets looked at, the better, just in case there's any problem with it that needs to be fixed. Okay. So if you have questions, please, send them right away when you get them. Okay. All right. Now there's another reading assignment. There's this website called Scratch a Pixel, which is kind of an okay online book on computer graphics. It's kind of like one of the better known online books on computer graphics. It's got a lot of information in it, though. So any individual page of it is usually pretty good, but the whole thing together is a bit odd. But anyway, here's a page on what we're going to be starting to talk about today and next week: perspective projection and then rasterization, the two main steps in computer graphics. So let me show you what I mean by that. Okay, uh, let me download the render. And unzip it. So far, we've been talking about the data structure going into the render and the data structure coming out of the render. The data structure going into the render, or the data structure going into the render is the scene data structure. The data structure coming out is the frame buffer. Then here are the algorithms. And if you look, there's a pipeline which organizes the algorithms into steps, and the algorithm steps are projection and rasterize. And that's these two pages. So here's a page about projection, and here's an explanation of rasterization. Now, the only thing that this rasterization gives you a fairly good sense of what we're talking about, but one problem with it is it's really talking about triangles, and we're still talking about lines. So it mostly talks about rasterizing in general, but it mostly talks about rasterizing whole triangles, and we're rasterizing lines, which is actually easier. So it's not like this is not going to be, this is still pretty relevant because rasterizing lines is basically, kind of like the edge of the triangle. Okay, so this is a kind of a good explanation of rasterizing. Their language of choice is C++, but when you look at a snippet of C++ like that, it's not all that much different than a snippet of Java. But this is a C++ data type. But it's pretty readable from the point of view of Java, because Java is just a derived language from C, like C++ is. Okay, so there's two reading assignments: projection and rasterization. Okay, and what I want to do, finish talking about this little chunk of code here called simple example. Just finish doing this example here. It's kind of interesting. And then we'll start talking about the rendering. Like, what we've been doing with this simple example is we've now traversed almost all the code in this scene package. We've looked at the camera class, we looked at the line segment class, the model class, the scene class, and the vertex class. And we saw most of those classes are pretty simple. Some of them are nothing more than a constructor and a toString method. Several of them are just a line segment, and vertex are nothing but a constructor and a toScene, okay, a toString method. So we've gone through the code in this data structure, and what we essentially did was see that it builds this tree data structure. Oh, when I double click on there, that's weird. Huh. I never even noticed that. Let me see something funny. Did anybody see something funny? What's wrong here? If I build the Java docs, okay, if I build the Java docs and enter the Java docs at the beginning, this page is this page. What I didn't know, which is kind of odd about the Java doc, this page is missing all the styles and stuff. So if you just open this page, it doesn't look right. You have to open it through, for some reason, I don't really quite get this. Oh, they've transformed it to a different page. It isn't this page. See, this page is overview.html. This page they generated is overview summary.html. Oh, so they generated a new page out of this page. And then the new page is formatted better. See, it's got lots more styling. Okay, so I didn't even know that. I thought that this page here was the generated page. So that means that, yeah, so this overview summary page was generated from this overview page in the Java, in the package. JavaDoc's kind of nice. JavaDoc does a lot of nice things, but I thought that was the overview page. I hadn't even realized that was just that would be processed to generate the overview page. So if you open this page, it doesn't look very good. If you open that page, it doesn't look nice like it should, like this. You can see it, you know, it doesn't look good compared to that. Okay. You see the tags still there. You see the little formatting tags instead of seeing it properly processed. Okay. Right. Now, what we've done is we've gone through the scene class, the scene package, and we see how it basically builds this data structure. Okay. So this data structure is made up of those classes. Okay. And we did it by tracing a program that built a scene. And as we went through the code that built the scene, that was this simple example, example 1. You know, we went through the code line by line. Create this. We looked at the scene constructor, looked at the model constructor, looked at the vertex constructor, how add vertex added the vertex to the model, then the line segment constructor, and then how add line segment added the line segment to the model, and then how you added a model to the scene. Okay, and that was those few lines of code pretty much take you through every line of the scene data structure of the scene package. Okay, so that's real important to understand how the input data structure to the render, to understand this tree data structure, which is the input to the render. Okay, now let's play around with it before we start talking about the rendering algorithms. Before we start talking about the rendering algorithms, let's look at some more of these examples in this folder. Okay, in this folder called simple example, there's actually 5 example files. So I want to show you just something, I think it might be helpful for homework 1 if we go through these a little bit more. Okay, so if I run this program, it generates a frame. That's what I mean by a decorated square. That's this decorated square. Okay, so the program created an empty model. So we might put out here, this is so far an empty model. The constructor builds an empty model, and we looked at the code. You can go back and check, but that constructor builds an empty model. There's no vertices or line segments in it. Okay, so then I put these vertices in it, which are these 8 points: 1, 2, 3, 4, 5, 6, 7, 8. Okay, those 4 corner points and the 4 midpoints, and you can go through and figure out which ones are which. Like -1, -1. Okay, I put them 3 units back behind the XY. They're in the Z plane, -3. The Z equals -3 plane. Then this is -1, -1. So that's going left and down. So I start with that corner there. Then -1, 0. That's that corner there. Then -1, 1. So actually the points go around the square in that order. Okay. So as you go down this list, you're starting over here, and you don't there. Points don't have to be in any order in a model. You can put them in any order. You can put this one, then this one, then this one, then that one. You can put them in a random order, but that makes it hard to build the line segments. If you put them in the right order, it makes it a lot easier to build the line segments. So now look at, remember, it's 0, 1, 2, 3, 4, 5, 6, 7. Now I go down here to the line segments. 0, 2. That would be this edge 0, 2. Notice I could have gone 0, 1, 1, 2 and created 2 line segments there. And that's actually totally up to me. Is there a good reason to do that or not? Okay. And I just chose to make one edge here that went from this vertex to this vertex. Okay. I could have created 2 edges from that vertex to there and there to there. Okay. So I chose to make it from here to here. Then 2 to 4. Skip over that one and just go from there to there. Then 4 to 6, 4 to 6, then 6 back to 0 to close the square. 6 back to 0. Okay, so that created the outer square. That was 4 line segments. Then I go back to 1, which is this guy. Now I do the odd ones, 1 to 3. Okay, so 1 to 3, 3 to 5, 5 to 7, and 7 to 11. Okay. If you put your vertices in a model in a nice order, it can be a lot easier to generate the line segments. Okay, so I created this thing called a decorated square. Okay, and then it's if it wasn't pushed all the way back, it would fill up the screen. So it's pushed back to make it smaller. Because remember, farther away from the camera you are, the smaller you appear. So it's been pushed back into the Z equals -3 plane to just kind of be a nice size. Okay. Okay. All right. Now what I want to do next is generate 5 of these guys. I want a program that generates 5 of these models. So let me show you what it looks like. What I mean by, oops. So look at example 2. Okay, here's 5 of them. There's the original one. And then there's one moved up to this corner, one moved up to this corner. So I just created a geometric pattern. Okay, by taking 5 of these and laying them kind of around, they're not sitting quite at the corner. I just thought that looked kind of nice. So there's a little bit of space in here. So I made a design out of 5 instances of that thing there. So let's look at how I did that. I'm going to show you 2 ways to take this one pattern and make 5 of them out of it. The first way is a kind of a cheat. Okay, so here's what we're doing over here. I build that model. Okay, then I render it to the frame buffer. Now that's exactly like over here. I built the model and rendered it to the frame buffer. Create an empty frame buffer. So this is an empty frame buffer. Okay, then I rendered the scene into the empty frame buffer. So over here, I create the model and rendered it into the frame buffer. But then I move the model to a different location and render it into the same frame buffer. I'm exposing the model. This is like an old-fashioned photography trick of exposing something to your film more than once. This was a common trick, especially in the early days of photography before you had Photoshop. You could create unusual images by having the camera reuse the film. you expose the film 2 times. So I'm rendering to the frame buffer once, and then rendering to the frame buffer again, but I move the model. So I update all the vertices in the model. So I move it. What I did here was I moved it right, which was take this model and move it right. I move it up. Then I move it farther back. By making it move farther back, it gets even smaller. So that's this image here. So this one, which was back at z equals -3, this one's back at z equals -5.5. So it gets even smaller. All right. Then I move it again by moving it to the left. See, I subtract -3 from all the vertices. So I move it left. And it's still far back. I notice I don't change the y coordinates, I don't change the z coordinates, I update the x coordinates. So I move it left. Okay, render it again in the same frame buffer. Okay, then move it down, render it again in the same frame buffer, move it right, render it again in the same frame buffer. Finally, after the last rendering, then the frame buffer gets dumped. Okay, now this is a common graphics trick, just like it was a common trick back in the early days of photography to expose your film more than once. This is a way to get a model in a scene in a lot of places, but it won't work in a game, because in a game you have to have the model, you need the models in the scene all at the same time. There's only one model in the scene, and first it appears here, and then it appears here, and then it appears here, and then it appears here and here. You can't do that in a game. In a game, you need all your characters on the screen at the same time. You can't put one character in the scene, expose the frame, put another character in the scene. I mean, you could do that, but you'd have to do that super fast. There's no game that can do that kind of thing super fast. So in a game, when you have 1/60 of a second to build a frame, you put all the models in the frame and then render the frame. So now let's look at the next example, which puts all 5 models into the scene at one time. Oh, notice that the scene only ever holds one model. As this code progresses, it's real important to realize that that scene only holds one model. And then I'm just constantly exposing more pixels in the frame buffer, so I'm getting a picture of 5 models, but the scene, every time I render, I'm rendering one model. That scene only has one model, but I'm overwriting the pixels that are already in the frame buffer. Okay, so that's a trick. It's a common trick in animation when you can do offline rendering, what we call offline rendering, where it doesn't matter how long it takes you to build the frame. So this might be an efficient way to build a complex scene. Instead of trying to have 100 or 1,000 models in the scene all at once, it may actually be more efficient to put some models in the scene, expose the scene, add more models. I think they actually do it that way pretty often. They might do like all the background stuff first. So they might put all the background stuff into a scene and render it, and then just start adding foreground characters into the scene and rendering them maybe as a group or one at a time. So I think this is actually a fairly common technique in really high-end rendering. Okay, but what if we wanted, what if we want to do it like a game does it? All 5 of these models should be in the scene at once. Okay, so next example is going to put all the models in the scene at one time. Okay, now the way I'm doing it is kind of, what happens is I'm going to end up with a huge amount of redundant code, because look what I'm doing. I've got an empty model here, okay? And then I fill it in. I add it to the scene. So I create an empty model, add it to the scene. Then I create another empty model, fill it with the same data. Then I move it to make it a different model in a different place. So I create an empty model, put data in it, add it to the scene. Create another empty model, add data to it, but it's the same data I added here, but I have to do this code all over again. Then I move that model. Then, but actually, I add it to the scene before I even move it. It doesn't really matter what order you do this in. You could add it to the scene, then move it, or you could move it, then add it to the scene. So I happen to add it to the scene and then move it. Then here's a a third empty model, put the same data in it, add it to the scene, move it to a different location, another empty model, fill it up with data, okay, add it to the scene, move it, and then there's the fifth empty model, fill it with data. Okay, so the question is, how do you get rid of all this redundant data? And it's not going to be something like a for loop. This would be, this is not something begging for a for loop, and it's not begging for a method either. Like you could put all this code maybe in a method. That's not really the right idea. Does anybody know what's the right way to get rid of this redundant code? Keep building an empty model and stuffing data in it. Empty model, stuffing the same data in it. What's the right way to fix this? Anyway, the answer is object-oriented programming. Does anybody see what object-oriented programming tool would I want to use here?
Wouldn't it be that copy of method? Like,
pardon me?
Wouldn't it be that copy method? I forgot what it was called.
Clone?
It's a copy of the current instance.
Oh, that's an interesting idea. Yeah, what if I took this model and cloned it? Okay.
Yeah, the clone method.
The clone method. Yeah, that would be a way to solve this. It's not a particularly, that's not the really well organized way to solve this. Okay, but that would be a way to solve it. You could clone this object, so you'd get a duplicate of it. Then you could move the duplicate, put it in the scene, then clone it again, which would give you a third object, which would be another duplicate. And then move you. So you'd start off by, well, you could clone this one, and then you'd have this one. Then you could move it. Then you could clone this one. That would give you the third one, but then you'd move it a certain way to get the fourth one, to put the third one in position. Then you could clone the third one, which would give you the fourth one. Then you'd have to move it in position. Okay, so that would be an object-oriented strategy. Okay, but it's not the most general solution to this problem. Anybody think of another object-oriented technique that would solve this problem?
Would you create another class just for the one of the shapes and then instantiate like 5 instances of it?
Yes, yeah. So the solution is a constructor of a class. Because what am I really doing here? I'm building an object. I mean, if you look at it, what I'm doing there is building an empty object and filling it with data. But that's what constructors do. They initialize an object for you. So this is really supposed to be a constructor of something. Well, what should it be a constructor of? It's supposed to be a model. So what should this be a constructor of? What would be the right, what's the object-oriented approach? I need a model. I need a constructor, but I also need a model because I put models in the scene. So this should be a constructor because that's what it's doing. It's building an empty object and populating it with data. But I need a model. So what kind of constructor do I need? How do I build a model that's a special case of a model?
Yeah, it would derive from the model class. Would be
I want
like a new class.
Yeah, I want a subclass of model. I want to define a subclass of model, and this will be the constructor of the subclass. Then a subclass of model is a model. Okay, so look at example 4. That's where this is done now. Okay, in example 4, here is a model here's a class that extends model, and I called it decorated square. Okay, and see this code here is exactly that repeated code that kept appearing over here over and over again. Notice that this code here is exactly that code there. Not exactly. Notice the difference. Who am I adding vertices to? What's the way to explain it? Yeah. Now pretend you're explaining this to a CS 123 student because you're a tutor or something, and you have to explain to them basic Java programming. Who am I adding things to here? How would you go? I'm adding things to what? To this guy, right? Where'd he come from? The line just above. I built that empty model and I'm adding to the empty model. Who am I adding to here? Who am I adding things to? You should be able to give a good answer to this. This is one of the deepest questions in object-oriented programming. Going from here to here, I ask you, who am I adding this vertex to? And you should have a good answer to that, because this is to be an interview question.
The inherited properties,
Pardon me?
the inherited instance methods from the
No.
model.
No. Who am I adding data to? Here, who am I adding data to? The object I created in the line just above. I'm adding data to the object I created in the line above, which is empty. Who am I adding data to here?
The object of the class or the instance of.
Explain it better. Who am I adding the data to here in this line of code? You're on the right track, but you should be able to give it a much more concise answer.
You're adding to the decorated square, just the class in general that extends.
No, I'm not adding it to a class in general. See, you're getting off the track now. See, yeah, I had it better before. Who am I adding things to? Who am I adding vertices to? I tell you, you've got to be able to answer this question, because you'll get asked it. You'll get asked it in a less opportune time than right now. You'll get asked it in an interview. You know, people will walk you through code like this and start asking you questions like this. Who am I adding data to?
The instance of that class.
Pardon me?
The instance of that class.
Which, you say the instance. Well, which instance do you mean? Over here, I'm adding it to this one I just built in the line above. All right? I'm adding to the object I built in the line above. Who am I adding to here? Which instance?
The calling object, so whichever one is.
There is no calling object. See? There is no such thing here as a calling object.
So the object that is created using the constructor.
Exactly. I'm adding to the object that's currently being manufactured. I'm in a constructor. I'm adding to the object that's only partially built at this point. This is what we mean by a constructor. The constructor is building. See, that's why I said that you don't have a current object. You don't have a current object. You didn't have a call. You didn't remember, when you call a constructor, you call a constructor with new. There is no calling object. You call constructors with the new word. So there is no calling, and that's actually in Java, that's what this means. This means the current object being built, which at this point is only half built. And then here it gets the other half built. So I'm adding to the object that's currently being built by this constructor. When you get to multi-threaded programming, this is a really important issue, because in the middle of this code, I have something called a partially built object. And in multi-threaded code, a real common source of bugs is to start having somebody use your partially built object. And you have to put locks around constructors to prevent people from using partially built objects. You never see them if you don't write multi-threaded code. But if you write multi-threaded code, a real common problem is to start seeing objects that are only half built. Like this one's only half built. At this point, at this line here, it's got vertices, but it has no line segments yet. It doesn't have line segments until after that line of code is executed. So I've got a half-built object at that point. And that's what the word this means here. I'm adding to this object that's being built. Now, to make things kind of confusing, that word this doesn't have to be there. That's legitimate code. Now I ask you, what am I adding this to? Well, there's not even something there's no calling object here. Because there isn't, in the Java language, the word this doesn't have to be there. It's just there to make it easier for you to think about sometimes. So, but I'm adding that data to the object that's under construction because I'm in a constructor. So I'm in the process of manufacturing an object and I'm adding to the object I'm manufacturing. Over here, this is why this is kind of bad. This is actually bad programming style because what I've got here is an empty object, an empty model. At this point, I have a model with vertices and no line segments. Can I actually use that object? The answer is no. It's really not very useful. It's got vertices, but it doesn't have line segments. If I rendered this object here, my renderer would blow up and give me error messages about lack of line segments. This is actually bad programming style because I'm working with partially populated objects, which is really a bad thing to be doing. You shouldn't work with partially constructed objects. So this code really belonged all in a constructor so that when this constructor returns, you have a fully built object. And if my renderer was multi-threaded, I would have to have some way of making sure that these objects never get seen in a half-built state like they are here. Here I see at the end of, in between this line of code and this line of code, I have a half-built object. Not a good idea. You know, in a code review, somebody might point that out and say, you know, this is really not good code because you actually are exposing at line 31 a partially initialized object. It's not fully initialized yet. It's a model with vertices, no line segments. It'll blow up if you try to do anything with it. If you try to pass it to the renderer, it'll just blow up the renderer. Okay, so I really should have this code in a constructor. Now, for a lot of simple projects, it's okay to have a partially built up object. We do this a lot, especially to explain ideas. Create an empty model, add some vertices to it, add some line segments to it. But overall, it's not such a great thing because at this point, you know, like I said, I have a partially built object. It's not complete. It cannot be rendered yet. It's better programming style to make use of constructors as much as possible. Okay, so over here, I put the code that puts data in the object is now where it should be in the constructor of the object. Okay, and I'll go ahead and put back to this because it makes it a little bit easier to read. I'm adding vertices to this object that's being built. And now I'm adding the line segments to this object that's being built. And then I return. Notice that there's no return on its constructor, remember? Because it's not returning anything. It's building something. You know, famously, constructors look like method calls, but they don't have a return value because they don't really return something. They build something. It's kind of a, you know, constructors are like a special case of things. Remember, this calls the model constructor, and like who built, I'm adding a vertex to the vertex list, but where did the vertex list come from? The superclass constructor built it for me. So if I go back over here, here's the default constructor in the superclass. Here's the constructor that takes a string name. This line of code calls the superclass constructor that takes a string name. So super name. So I go over here, there's the superclass constructor takes a name. What does it do? It calls this constructor. Now this word is not the same as this word. And this is why this is a bad thing, because this word is not the same as this. This is not the same as this. And it was really bad with the Java people to say this is not the same as this. Okay, what's this? This highlighted this means what?
The default constructor.
Yeah, well, it means constructor. No, it doesn't mean what means the default constructor, the pair of parentheses after it. The word this in a method call means a constructor. Then you have to look to see how I called it. So I was calling the default constructor. So the this here means a constructor, okay? So this means a constructor when you call it like a method. What does this mean? What does this mean?
The model object.
Which model object?
Was the one that's currently being made?
Yes, the one that's currently being constructed. It's this object, the one currently under construction. So this is a constructor call that helps build the object that's currently under construction. This is a reference to the partially built, currently built object. So this is a constructor and this is an object. This is a constructor call to help us build the current object, and this is a reference. Now, can I delete the this here? Remember I said over here, I can delete the this. Can I delete the this here?
No,
Why not?
because it will just not assign it.
No, you have to tell me exactly what's wrong with that.
Primary.
It's a name. It's referring to the name that's being passed.
Yes, this name is in scope right here. So what here I'm doing is this will compile and this will run. What does that line of code do? It compiles and it runs. What does it do?
Does nothing.
No, it does do something. It'll generate code and the code will compile and run. What will the code do?
It's just reassign whatever's in the value name.
It'll copy what's in name back to name. It'll literally just copy what's in name to itself. It'll get what's in name and put it back in name. It'll get what's in name and put it back in name. Okay? So what does that do?
It gives the object's name attribute, the name that's in the constructor.
So what is it doing? That is now what?
So then that'll be what was passed into the.
Yeah, that's the
context.
parameter variable. This is now what?
That is the attribute of the object that's being created.
So that's the parameter named name. That's the attribute named name, the attribute in there. Suppose I don't want the this there. How can I fix this code?
Change it to be called something else.
Change what? You said change this. Change what?
Change the first name.
Which is the first name? Change this first name?
Yes.
No.
Or the other one.
But what?
Or the other one. Just call
Well,
it.
no, you said or. No, it isn't or the other one.
Change the parameter to be called something
Yeah,
else.
change the parameter name. A lot of people do this. Okay, now I don't need this here. Why do I not need this now?
Because the names are different, there will not be any overriding.
I can't say again.
Because the names are different and the parameters are clear, the code will know that it has to
Well,
set
there's no-
that attribute. Yeah.
There's no name clash anymore, right? That's a different variable name than that one is. So now the compiler looks for this name. Where does the compiler find this name? Where was it declared? Where was this name declared? Where's the declaration of that name?
In the parameter.
In the parameter, line 80, okay? Where's the declaration of that name?
Line 58.
Line 58. See, there's no conflict now. That name and that name are different. When you do this name is that name, and so is this name is that name, because it shadows, it hides that name. But when you do this, now you're scoping that name to the object. So it's that variable there. This scopes that name to the object, not to the parameter name. Okay, so this is acting as a scoping rule. It's saying use the name in this scope, which is the fields of the object. Okay.
Professor, a question. So name in the parameter, since it's declared as a final, if you don't have this dot, how would that assign to itself?
Like this?
Yeah.
It won't compile. You're right. I forgot about the final there. It would not compile because of the final there. Yeah, the final, actually, that would help you, notice that would help you fix a bug. That's one of the reasons why I put the final there. If you accidentally did this, it won't compile because you're now trying to update a variable that's final. So this is actually, this is one of the reasons I put a lot of these finals in there. They help you catch little bugs. So now the final doesn't need to be there. A lot of people don't put it there. Now I wouldn't catch that bug because now this is a regular parameter. There's nothing to stop you from updating it, even though you're updating it with itself. So notice that, yeah, that's a real good point. This will not compile because of the final. And that's actually kind of one of the reasons why the final's there. The final is saying to the compiler, I'm not going to change this parameter. I just want to pass it in. So it should never be changed. So if I do change it, I screwed up. So I mark it final to make sure that the compiler knows that I don't think this thing should ever be changed. It's an input parameter. If I do this, the compiler is saying it's just a variable, just like any other variable. You can update it if you want. There may not be any point in updating it, but if you want to, you can. But I want to tell the compiler, no, I'm never going to update this variable. So I mark it final. Then if I goof up with something dumb like this, the compiler will flag it. The compiler will say, you cannot update a variable like now. Oh, I can't, let's see. To compile, let me go back and compile this now. So I made a change to the render. So build all the classes in the render. Bingo. Compiler said final parameter may not be assigned. See? Helps me find errors. Really well-written code will help you find errors. And there's lots of little tricks out there for how to write really well-written code. And that's kind of one of the things I want to show you is like these little weird tricks we have for trying to prevent strange errors from creeping into code, like accidentally doing something like this, okay? So putting final there helps you prevent a subtle mistake like reassigning a variable to itself. In this case, what I really want to do is say this. Now, there's a style of programming where people don't ever have the same name for a parameter as they have for a field. So they would do something like the new name. The name gets the new name. I actually don't like that. And it's not, that's a style you see in a lot of textbooks, and you don't see it used much in the real world, of giving your parameters different names than the thing that they're setting, okay? Because then you have to think real hard. Well, what's new name? Why is it a new name? Where's it going to go? You know, whereas if I do it the way I did it before, right away you say, oh, that's going to be the name variable. It's a constructor, and you're giving me the name parameter. And it's just up to me to make sure I do the code right. So it's this name gets the new name. This is the new name, and this name. But then the fact that I gave them the same parameter name, I gave them the same name is helpful. Then I see that this is exactly where that guy's going to go. It's one of my fields. Okay. So now, not everyone likes that trick. Not everyone likes that trick. A lot of people would prefer that this guy. So a common trick is to put a leading underscore on the parameter name like that. So now it's more or less like that name there, but it's technically a different name. Then if you don't want to, you don't need this. Okay? Lots of different styles out there, lots of different styles, but you have to be careful that you actually use a style that makes sense. All right, now let's go back over here. Okay, what we did to get rid of all this redundancy is we said, well, what we're doing is we're building an empty model and sticking stuff in it. Building an empty model, sticking stuff in it. Well, that's what a constructor does. Constructor builds an empty model and sticks stuff in it. So, but I need a constructor of a model, so that's a hint that I need the subclass model. So I go over here and I subclass model, and the only thing in the subclass is a constructor. I don't need anything else. I don't need any new methods. I don't need any new attributes. I really just want this thing to build itself. So I want this thing to build a non-empty model with the data of that's equivalent to a decorated square. Then my code just now goes through and builds a decorated square, builds another decorated square, adds it to the scene and moves it, builds another decorated square, adds it to the scene, moves it. Now it still looks like I have redundant code. That looks a lot like that. And that would be a good thing to move into a method. In your homework assignment, remember I gave you a hint of something called move model and move models. Move model is really this code moved into a method so that you don't keep typing it over and over again. So in the homework assignment, I said, don't really do this. This should be in a method because I really should not be repeating this code over and over again. But in this example, I'm mostly getting at the object-oriented thing. I wanted to move this code into a constructor. That's actually, I think, the harder thing for you to see. Moving this code into a constructor is more subtle than moving this code into a method. I think you all would see right away that, yeah, that should just be in a method. You just keep calling this for loop over and over again. You've just got a few different numbers here, here, and here, 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 and here. Those are the parameters to the method. Delta X, delta Y, delta Z. Okay, so there's a pretty obvious method right there. That's those few lines of code with a parameter delta X, delta Y, and delta Z. The more subtle thing is that this is a constructor call. Okay, and like somebody said earlier ago, a clone would work here, but cloning is another big hassle. I want to go back and say cloning, I would think, is not really a good solution here because almost everybody hates cloning in Java. Cloning doesn't really work well in Java. You can Google cloning and you'll see page after page where people tell you don't use clone. It's got serious technical problems. Okay, so unfortunately, the cloning idea is it's a very object-oriented idea. In some situations, it wouldn't be a bad strategy to take your basic object and clone it and then modify it, then clone it again, then modify it. But a better solution would be to subclass and make a construct. Well, I wouldn't say better. In some situations, the better solution is to subclass and have a constructor. And then every once in a while, a good solution is cloning. You know, cloning an object, modifying it, cloning it, modifying it, cloning it, modifying it. That can work. I don't think that would be the best answer in this case. In this case, the best answer was subclassing. Now, notice I put the subclass in the same file. So it's a private class. I didn't write the word private there, but it's actually a private class. That means nobody else can use this class. So even though I think this is a really great object and could be really useful, nobody else can use it because I buried it in this bigger class. So example 5 fixes that by example 5 saying, well, really what you should be using is an externally defined class. So see, example 5, see here I defined a decorated square class in its own file and it's public. Now anybody could use it. If I wanted to, I could put this in my package of models. Remember, I've got a package in the render of a whole bunch of models that I think are kind of useful. And if I really thought decorated square was really great, I would put it in this package. I would move this class file into that package so everybody could use it. Not that I think that this isn't worth doing that, but I could have put, I would put a package statement up here and then move this file into the package class, then it would become part of the render itself. Here it's just part of this one project. So this model is a model in this project because it sits in this folder and it's not part of the render itself. But now any file in this project can use this. Whereas in this example here, this class can only be used by example 4 because it's inside there. And what's interesting is that, let me compile example 4. Here's an interesting little Java quirk. See that class file? Notice it's no longer buried inside of that class file. See, in the source code, this class file is buried in this class file, but in the compiled version, they're not. That class file sits by itself. But the truth is, nobody can use it. It's sitting there at the top level, but it's marked private to this class, and no other class can actually use that class because it's marked private. So Java compiler breaks them up into 2 classes. It takes this file and breaks it into 2 class files, a class file called example4 and a class file called decorated square. Oh, that should have that should have been E4 for example 4. I renumbered these things and I have to go fix that. It was supposed to be decorated square in E4, but I kind of changed the numbers. I forgot to update that. That's what the E stood for. This was the decorated square in example 4, so it should have been E4 here. So I should update that. Okay. So, but it's interesting to see that the compiler actually generates 2 class files. Okay. Now, on the other hand, for example 5, when I compile example 5, I don't have to compile this file by itself. I don't have to compile this guy. If I compile example 5, Java automatically compiles what's needed. So when I compiled example 5, this guy got compiled. This class file is public. Anybody can use it. I can mail it to you and you could use it. I could email you that class file and you could use it. If I email you that class file, you can't use it for anything unless I emailed you example 4 along with it. Okay, that class file is a private class file. This one's a public one. I could email you the class file without the source code and you could use it. You might be curious what's in it. Yep. You know, if somebody sends you a class file without any documentation, you won't necessarily know very well what's in it, but you could use it if you were told what's in it. Okay. All right. So your homework assignment is for you to create these. You're going to create an N and a W model file. So your homework assignment is to create something like this. You're going to extend model with an N. I did the P for you, and you need to do the N and the W. Now that's to do things the good way. You could have done the homework assignment the bad way, like example 2 is, where you could have just created an empty model, stuck what's in it to make it an N, then create another empty model, stuck what's in it to make, you create an empty model, stick N's data, an N data worth in it, create another empty model, stick a W's worth of data in it, and then go along your happy way. Okay. And you could do homework assignment that way, create empty models and stick the data in them that makes them to a N or a W. But I don't want you to think that way. If you need an N and a W, you should create a file called N extends model and a file W extends model. You should create subclasses of model. That's the better way to do things. Okay, so this contrasts the somewhat simplistic way of doing things of create an empty model, put things in it, versus define model subtypes of, extend the model class and have the constructor put things in the model. Okay. Remember, when you do it this way, you have there's problems here in that at this point, that's a partially constructed object. At this point, it's a it's an empty object. You can't do anything with it. That's kind of bad. You could make the case. Here's something interesting. You can make the case that this constructor shouldn't be there. Why not? Why did I just say you can make the case that I shouldn't have that and that? What's wrong with this guy and this guy?
They're both public.
And what's wrong with them being public?
The one with no parameters should just be private since it's called from the one that's setting the name anyway.
Yeah, but what's wrong with it being public?
It's not fully built.
Yes,
It has
it returns a only partially built object, which is what I just said. You know, that gives you this stuff that misleads you into thinking that this is an object that you can use. It's returning to you an object that's useless because it's only potentially partially built. So a better style here would be, this should be private. This one should be private also. But then I need to have, see, then here's the but then I have to do something, you know, then here's a constructor that you would then use, but then you would have to build your own vertex list, build your own line segment list, and then call the constructor with all of them. And that turns out to be not a very good thing either. What you could do is you could make this so that there is no what you really could do if you want to solve this problem is you could mark this class abstract. What does that do? Can we know what that does if I mark it abstract?
You cannot instantiate it. You can only inherit it.
Yes, exactly. You can no longer instantiate it. So then that would prevent anyone from doing this kind of thing. They would always have to do this kind of thing. They would have to instantiate a subclass of model. There would be no constructor for model. Now, by marking it abstract, the subclasses can still call this constructor. This thing could call this guy. The subclasses could call this, but no, you could never call, you can't call this thing directly. Okay? Okay. So that would, I didn't choose to do it that way because for teaching purposes, it's nice to be able to just kind of build up these examples slowly like this. I think this has got got good teaching value. But if it was a real design issue, you can make the case that there should never be partially built models. So you should never be instantiating the model class. It's just there to subclass. You do that by marking it abstract. So it's only there for subclassing. And then the subclasses will always build complete models for you. The subclass will always build a complete model. Okay? So you can make the case that this guy should be abstract. And actually, I could change that in a future renderer because in the future, we stop doing, eventually we'll stop ever doing this of building an empty model and sticking things in it because it's really not a great idea. But it's kind of, it makes it easy to do little test code. It actually makes for, it makes it real easy to write test programs where you build a real simple model with 2 vertices and 1 line segment. Okay, so the advantage of this is that I can build really small models for testing purposes. That's why I've actually left it like this. But from a design point of view, it's bad design. I'm letting you build models, objects that are incomplete and possibly dangerous. Okay, so I could take the point of view that models should be abstract, so no one's allowed to build model objects. So the only subclasses can build model objects, and subclasses should always populate the object before they return it. But I'm going to leave it. I'm going to leave it like this because I think it's really useful to build small models for learning purposes and for testing purposes. I write a lot of test cases where I just build a model with 3 vertices and 2 line segments, or 2 vertices and 1 line segment. I build a lot of test models that way. Okay. Notice how we're talking about design, okay, and talking about kind of subtle design. You know, we're building a piece of software that's not, you know, 2 files and a couple hundred lines. We're building a piece of software that's, it's 4 packages. There's a bunch of, a bunch of classes, a bunch of packages. We're really building something that's non-trivial. So we really should start thinking about real design. Okay. So all kinds of little design issues, like we said, when do you use this and when do you not use this? How can you make effective use of superconstructors? Like what's the nice way to make use of superconstructors? What's the nice way to make use of other constructors? Like this constructor calls that constructor. Notice that this constructor didn't call any other constructor. This one did not call this other constructor. And that's because this one is given the vertex list already. So it doesn't want to call the superclass constructor, which builds a new list and then throws it away. It would be a mistake here to call this. It wouldn't be a mistake. It'd just be kind of dumb. Because what you do, if you put that line of code in there, you'd go up here, you'd build the empty array list. Then you'd go down here and replace it. And the one you just built would get garbage collected. So you'd be building an empty list for no purpose at all. And you will see people do this kind of stuff. People will just habitually call this in their constructors, and they don't stop to think about, is that really a good idea? In this case, it wasn't a good idea because that would create an empty array list and then immediately replace it with this array list, which means that this empty one gets garbage collected. It gets created, then garbage collected. Then the same thing with the line segment list. The line segment list up here, there'd be an empty line segment list created. Then it would get replaced by that line segment list. So the empty line segment we just constructed would get garbage collected. So this would be a mistake. Okay, so I don't call that. So all kinds of little things like this. Thinking real hard about our code and always asking, what exactly is our code doing? If I put the this in there, I want to know exactly what it's doing. Sometimes you would see it there, sometimes you don't see it there. I want to know exactly what it's doing so I can think, should it be there? It's not really wrong to put it there, but in a code review, somebody might catch that, well, you're putting it in there, but you're just wasting, you're wasting CPU cycles because you're creating empty lists and then deleting them immediately. So it won't cause bugs. The word this was a really lousy choice for this. This is not a bug, but this is not a good idea either. Not a bug. Okay. So notice we can get to things where things are not bugs, but they're not good ideas either. So we're past the point of view of just trying to get the bugs out of our code. We're also to the point of wanting to get good things in our code and avoid bad things in our code. So that's not a bug, but it's not a good idea. Okay. Oh, and all these thises need to be there because I'm reusing the names here. See, I reuse the names there. So all of these thises need to be there because I kind of like the style of having the constructor parameters have the same names as the field method, the field. I kind of like that style, but there's plenty of people who don't like that style. They don't want the constructor parameters to have the same name as the object attributes. Okay, so that's kind of a more personal style thing there. Okay, now any question about going through a lot of ideas fast. There's a lot of object-oriented ideas kind of going through fast, but I hope you're starting to think about it. Anybody got any question? Let's switch to another example. This example here of the triangle. Okay. Now this is in the top level, so I can compile it right in. I don't see these were not at the top level. I had to compile them using the build scripts. This one's at the top level of my package, so I can actually build it. What did I do wrong? Did I make some change? I mean, did I goof up? Did I change something while I was playing around? oh, I know what's wrong. Oh, this is a real subtle mistake. Oh, this is a really great, this is, see these build scripts? Okay, when I was in here, sometimes I use the build scripts and sometimes I use Dr. Java. Or I'm sorry, TextPad. The build scripts, see they just call Java C? Well, if you just call Java C, you're not sure which Java that is. So go down here, open a command prompt, find out who Java C is. I have JDK 11 in my path. So if I just go down here, the build scripts are using JDK 11, okay? But TextPad, if I use this tool, this is a problem with all IDEs. You have to really pay attention to what your IDE is doing. I've got my tools for compiling. Well, if I go and look at them, my tools in this version are using, well, it doesn't, unfortunately, it doesn't tell you which one they're using. Notice it just says compile Java, and TextPad isn't even telling me which version of Java I'm using. Well, this version of TextPad is actually using JDK 8. Okay, so this build environment, my TextPad is using a different version of Java than my build scripts are. So what that means is I need to clean everything first, get rid of the possibly, I can't mix up versions of Java in build scripts. I can't build some classes with one version of Java and some with another. Okay, so now I did a clean. Now I can go build here. See, it worked. Because I mixed up my builds. I had done some building with the build script and some building with Dr. Java, and I had incompatible versions of class files. Some class files built with one JDK and some class files built with another JDK. You gotta be real careful about build environments. You have to be really careful about them. All right, so now this one was built using JDK 8, but now I can run it. Okay, and it generates this movie. Oh, no, I'm sorry, it generates this file, a picture of I'm sorry, this one didn't generate a movie yet. It generated this picture. Okay, what we want to do is now trace this code. We have a few minutes, so we'll start it. We want to trace this code. Well, so far we've traced this part of the code here. What we just did in a different file, but we traced through calling the scene constructor, calling the model constructor, adding a model to the scene, construct a vertex object, add vertexes to the model, construct line segment objects, add line segments to the model. We did all this. We've traced through all this. That's tracing through the scene package. Okay. We want to now, then I build a frame buffer. You've played around with frame buffers enough. Now we want to start saying this line here. We want to trace the scene and the frame buffer going into the render. We want to start tracing the pipeline. Okay, so now we want to start looking at the pipeline. So in terms of the explanation of the code, we've seen enough of this. We've seen enough of this. Now we want to start looking at this, the rendering algorithms. Okay, all right. So we want to start looking at how we took the scene data structure, how this scene data structure got processed into the pixels in a frame buffer. I mean, here's this represents the idea of pixels in a frame buffer. So we want to go, we want to see how we go from the algorithms that convert this tree data structure into this 2x2 grid of pixels, the frame buffer data structure. Okay, so let's start tracing through that code. Okay, now we call the render method. Now notice that that is called on an object. That is called on a class name. What's the difference? Method on an object versus method on a class name. What's the words for you? What am I talking about here? Method on an object, method on a class name.
Render is a static method.
Yes, render is a static method in that class. Add line segment is an instance method in the model class. Okay, that's an instance method. It modifies a particular instance of the model. This is a static method. It doesn't actually act on any objects at all. It's like a C function. Static functions in Java are just like C functions. It just sits there in your namespace, but you have to say what class it was defined in. So that's a static method in the pipeline class. Okay, so I go up here, open the render package, open the pipeline package. There's the pipeline file. Okay, the pipeline file has this static method called render, and it takes in a scene, and it will render the scene into the viewport. What does this thing tell me? What am I signaling to the compiler or to you when I put this there?
You can't really change the scene. You can't add another. You can't assign anything to
Yeah, the scene's been built by somebody else. The renderer's job is not to modify the scene. So I'm signaling that to you and to the compiler. The renderer's job is not to modify the scene. Now here's a trick though. What is the renderer's job? It's not supposed to modify the scene, but what is its job? This thing should make you really wonder what's going on. What is the job of the renderer? What is the job of the renderer?
Modify the viewport.
Yeah, to put pixels in the viewport. His job is to modify the viewport. The whole point is he's supposed to be pushing pixels over into the frame buffer, like you did in your homework assignments. The renderer is supposed to update the frame buffer with new pixels. Well, if I said that this is signaling that I'm not changing the scene, how can this say that I am updating the viewport? What does final really, really, really mean here? And actually, what does it really, really, really mean here? Can I update the viewport if this guy's final?
You could update. You can't just create a new reference though.
Well, what is that? Okay, let me draw a picture. I think I have time. Let me draw one real quick picture. In Java land, if you've had classes with me before, I've shown you this idea a lot of times, and I'm going to show it again. Real quick. Let me see if I can do this real quick. I've got a variable here called VP. So the variable is called viewport. That's the variable. And it's of type, the variable is of type viewport. It's actually of type frame buffer dot viewport. You know, if you want to be really technical, it's of type frame buffer dot viewport. Okay. What's in this variable? We're running out of time, so somebody has to answer quick. What's in that variable?
An address?
An address of what?
An object?
Of what kind of object?
Frame buffer viewport?
Yes, it's holding the address of a frame buffer viewport address. And we usually draw it this way. We draw in the heap an object. What's the type of that object? That object is a frame buffer. That's a frame buffer viewport object. This, oh, whatever. Okay, this is a frame buffer viewport reference variable. This is a frame buffer viewport object. This reference variable points at the object. It holds the address of it. It's a pointer. You know, Java people don't like to use the word pointer, but it's a pointer. What does final mean?
You can't change where VP points to?
Yes. Final means you can't change what VP points at. Can you change this guy over here?
Yeah, you could change the
Yes.
properties of that.
Yes, you can change this guy. Final says you can't change VP. You can't make VP point at any other frame buffer object. That's not saying you can't update the frame buffer itself. Okay? So this is a subtle thing. It's really saying that this guy is never going to point at any other frame buffer. It's only, same thing here. This is actually not saying that I can't update the scene. I can update the scene. I just can't have this variable point at any other scene. So it's actually a little bit what I said, well, this is not signaling that you can't update the scene. It's actually signaling that you're never going to make this variable point at another scene object. But it might give somebody a hint that I'm not going to change that scene. But then over here, it's the opposite. I am going to update that viewport, but I want to signal to the compiler. Actually, this helps the compiler generate faster code. I want to tell the compiler I'm never going to change that pointer. That pointer is going to point at one object and never point at any other object. Okay? Subtle stuff. Yeah, we're going to start drilling into the language and seeing how the language works. Okay. All right. So we're now going to start. This is what we pick up. What day is today? Thursday. Next week on Tuesday, we're going to really go into the renderer code. What does the renderer code do? You know, the pipeline is going to go through this projection stage, and then it's going to, it's going to go through this projection stage, and then it's going to go through the rasterizing stage, and we'll talk about the algorithms in the code. So we'll go through the code and the algorithms for projection and rasterization, and that's where this reading assignment should help a little bit. Projection and rasterization. Okay, so we ran out of time. Anybody got any last minute question? Read a good book on Java. Now's a good time to, now's a good time to start really going back. Everything you've ever learned about Java, it's time to relearn it so that now you can say that you really understand what they were talking about. Because all these things were mentioned all through your years, but a lot of times you hear them and you don't use them. In this project, we're going to pretty much use in an effective way almost everything in the Java language, and we want to use them well. We want to use these ideas well. So, we want to use things like final in a good way. We want to use names. We want to use final in a way that helps us. Here, we want to know what it means and when is it a good time. Notice I even put final up here. Why would I have done that? What do I mean? Public final class. Okay. I'm gonna put. You'll see this code. I put final everywhere I can put final. I put final. Okay. And a lot of C++ programmers do this too. I put final everywhere I can. If I can signal to you that something's not supposed to be changing, I do. Okay. So I'm signaling over and over again as much as possible that there's no change happening in this variable. Okay. But then you have to be careful. It doesn't mean that that model can't change. The model can change. The model reference variable can't change. Can you change this? Can you change this? Those are two different things. Can you change the reference variable? Can you change the object it's referring to? If you can't change the object it's referring to, that's what we mean by an immutable object. Okay, so those are the kind of things we want to keep talking about, keep mentioning. All right, so I'll quit. Anybody, any last question? Okay, so if you have questions, please send me an email. I'll go ahead and end the meeting, and we'll meet again on Tuesday. So have a nice weekend. Bye.